Hello, this is Dr. Hanaa Assil, and this is June 2020 paper 2C, Excel Chemistry, and let's discuss the questions. So the first question was, a student is given a mixture of salt solution and sand. She wants to obtain pure water from the mixture. So she separates the sand from the salt solution. Which method of separation should she use? Remember, sand is something that does not dissolve. So to separate it from a solution, we use filtration through filter paper and funnel. Of course, the sand will be collected as residue, and then the salt solution will be the filtrate. The student then uses this apparatus to obtain pure water from the salt solution. So she does this simple distillation, and he says, name the pieces of apparatus labeled X, Y, and Z. So what is X? You should know X is thermometer. Y, where is Y? Y is the condenser. Z is a beaker. State what remains in the flask when the separation is complete. Of course, if I have a salt solution, the distillation removes the water into the beaker, and I'm left with salt in the flask. Then the second question is talking about chromatography. He says, in a chromatography experiment, a student uses samples of 3 pure food dyes, B, R, and Y. So remember that B, R, and Y are pure food dyes. He also uses samples of 4 unknown substances, S, T, U, and V. So S, T, U, and V are the ones we're testing. The student puts a small drop of each substance on the pencil line. The diagram shows the student's chromatogram at the end of the experiment. And then he asks, which of the unknown substances contain only one food dye? Of course, when I look at this, which one contains one food dye? Remember, the unknown substances were the S, T, U, and V. So which one has only one? It is the one that gives one spot, so that is S. Explain which pure food dyes are in substance V. Where is V? V, you're looking, V has which of them? B or R or Y? So you can see that there is a spot in V that is the same height as R, and there is a spot the same height as B. So that means that V contains B and R because it has spots the same height as the dyes. Calculate the RF value of the yellow food dye. How do we calculate RF value? He wants the RF value of Y. Where is Y? The RF value is the distance traveled by the spot divided by the distance traveled by the solvent. So from the pencil line, you measure from the pencil line to the spot divided by from the pencil line to the solvent front, and that comes out to be 0.7. State how the chromatogram suggests that the yellow food dye is less soluble in the solvent than the red food dye. Remember, chromatography separates substances based on what? It is based on their solubility in the solvent. The one that is more soluble in the solvent goes up further. The one that does not go up is not soluble or less soluble in the solvent. So, state how the chromatogram suggests that Y is less soluble than R. This is because the spot for R went up higher than the spot for Y. That means that R is more soluble in the solvent than Y. The next question says the box gives the names of some metals. Identify the metal from the box that burns with a bright white flame. Remember, which one burns with a bright white flame? You should remember that that is magnesium. In the earth, metals are found either in ores or as uncombined elements. Explain which metal from the box is most likely to be found as an uncombined element. Remember that uncombined elements means that I can dig up the earth and get this metal as it is. And that means that the metal is not reactive. So the one that is most likely to be found as an uncombined element is the one that is least reactive, so it is silver. And he's saying explain. Remember, when he says explain which metal, that means you tell me which metal and you explain why you chose that. So it is silver because it is the least reactive. This is the order of reactivity of four metals. The method used to obtain a metal from its oxide depends on the reactivity of the metal. Two possible methods are heating the metal oxide with carbon and electrolysis. I'm going to remind you again that the ones that are very reactive, more reactive than carbon, have to be obtained by electrolysis. The ones that are less reactive than carbon I can get by reduction with carbon. So explain which method should be used to obtain lead. Now, where is lead? You should look for carbon. Carbon is something that is below aluminium but above iron. So if I'm going to put carbon in that list, it is above iron. That means it's above lead, and that means that I can get it by reduction with carbon. So I would be using method 1 because lead is less reactive than carbon and can be displaced by it. He says include an equation for the formation of lead. That means that I start with lead oxide. If I'm going to reduce it with carbon, that will give me lead plus. You can either say lead plus carbon monoxide or lead plus carbon dioxide, and in that case you'll need to balance the equation. Then he says the diagram shows the arrangement of particles in a pure metal. You know that a metal is solid, that means it is regular rows. And we said if I'm going to talk about the structure, it is regular rows of positive ions surrounded by delocalized electrons. Now he's saying metals are often made into alloys. And you should know that alloys are a mixture of metals with other elements. So it can be metals with metals or metals with things like carbon. So that's alloys. And why do we use alloys? We said we use alloys because they are harder. Now he's saying explain why alloys are harder. Remember, alloys will have atoms of different sizes, and the atoms of different sizes do not allow the layers to slide over each other easily. Remember, if I tell you why are metals malleable, it is because the layers of positive ions can slide over each other. But when I have different atoms of different sizes, then the layers cannot slide over each other easily, and that makes the alloy harder. Question 4 is talking about alcohols, and he says, give the structural formula of the alcohol that contains one carbon. Remember that an alcohol has OH. One carbon must have a total of 4 bonds, so it has 3 hydrogens and 1 OH. Ethanol is an alcohol that can be obtained from glucose. Name the process that converts glucose to ethanol. You remember that we can get ethanol by 2 methods. One of the methods is by fermentation, and that is when I add yeast to glucose and it turns the glucose into ethanol and carbon dioxide. Now explain why this process is carried out in the absence of air and at a temperature below 40 degrees. First of all, it's in absence of air because the yeast does what we call anaerobic respiration, which requires the absence of oxygen. And in fact, if there is oxygen, then I will not end up with ethanol. I would probably end up with ethanoic acid, which is the oxidation product of ethanol. Now, if I use high temperatures, remember fermentation has to be below 40. If we use high temperatures, this would cause the enzymes to be denatured and the yeast dies. Remember, if we say what is the effect on the yeast is a living organism, so if I put it in very high temperature, it will die. But the enzymes, we don't say the enzymes die, we say the enzymes are denatured. Then he says, complete the table, and he says, I have ethanoic acid. How do we draw the displayed formula of ethanoic acid? Remember that Eth means 2 carbons, Acid means it has double bond O, single bond OH. So that is how you draw the displayed formula of ethanoic acid. Now, propanoic acid, he wants its molecular formula. Molecular formula means the total number of carbons, total number of hydrogens, total number of oxygens. So it has how many carbons, hydrogens, and oxygens? It is C3H6O2. That is its molecular formula. Now, what is the name of this compound? Remember that this is something that's an acid. It has 4 carbons. The acid that has 4 carbons is called butanoic acid. Now, name the homologous series that contains all of these compounds. Of course, all of these compounds are called carboxylic or acids, or they belong to the homologous series called carboxylic acids. The compounds in the table can react with alcohols to form esters. When preparing esters, I have to add a small amount of concentrated sulfuric acid. Now, why are we adding concentrated sulfuric acid? Remember, it is acting as a catalyst. So if I say, what are the conditions for preparing an ester? It is adding concentrated sulfuric acid as catalyst. Draw the displayed formula of the ester that forms when propanoic acid reacts with ethanol. Remember, we said, how do we draw esters? Propanoic, I start by drawing the acid. The acid is propanoic acid, so it is the acid that has 3 carbons. And then I attach, instead of the C double bond O, single bond O, H, I remove the H and I put the part from the ethanol, so that is 2 carbons after the COO bond. Esters have particular uses that depend on their properties. Remember that esters have a fruity smell, so we use it in food flavorings or in perfumes. The organic compound butadiene is a colorless gas used in the manufacture of synthetic rubber for tires. So this is the structure of butadiene. Explain why butadiene is described as unsaturated hydrocarbon. Remember, we said unsaturated means it has C double bond C. So these have C double bond C, so you can refer to it as unsaturated. Now, why is it a hydrocarbon? Because it has carbon and hydrogen only. Now, butadiene reacts with bromine water. Remember that all alkenes or anything that has a double bond would react with bromine water. What would be the color change? Remember that when I add bromine water to something that has a double bond, it turns from reddish brown to colorless, or sometimes we call it orange to color. The equation for the reaction between butadiene and bromine is shown. He gives me bond energies and he wants me to calculate delta H. Again, how do we calculate delta H? We said we are going to add up all the energy needed to break the bonds before the arrow. So to break the bonds in the reactants, this is a positive value of delta H. The reactants will break down and form products. Now, when the bonds form in the products, they release energy. So the overall delta H is actually the bonds in the reactants minus the bonds in the products. So let us take a look at this. What are the bonds that we have in the reactants? We have CH bonds. How many CH bonds do we have? We have 6 CH bonds in that butadiene. He tells me that each CH bond is, or it will need 412 kilojoules to be broken. So that is 6 times 412. Plus, what other bonds do we have? We have the C double bond C. I have 2 of them. So that is 2 times the 612 that he gives me. Plus, what other bonds do I have? I have a C single bond C in the middle. So that is 348. And I have 2 BR-BR bonds that I need to break. So all of this is the amount of energy needed to break the bonds in the reactants. Now, what do we have in the products? In the products, we have still 6 CH bonds Each of them needs 412, so I have 6 times 412. Plus, what other bonds do I have? I have 3 bonds that are between 2 carbons. Remember, we're counting the bonds, not the carbons. So I have a bond between the first carbon and second carbon, and then another between the second carbon and the third carbon, and then another between the third and the fourth, so I have a total of 3. C, single bond C, so it is 3 times the 3, 4, 8. Plus, I have CBr bonds. How many CBr bonds do I have? I have 4 CBr bonds. So 4 times 276. So that is the total for the bonds in the products. And then the overall delta H is reactants minus products. Reactants minus products. Here, the delta H comes out as a negative sign. If it comes out as a positive, you have to put the positive sign because delta H needs a sign. And the fact that this comes out to be a negative, this tells you that it is an exothermic reaction. Then he says a scientist does an investigation to find out if butadiene would be a good fuel. He burns a sample of butadiene gas and observes that carbon forms as black soot. Remember, the fact that carbon is formed, this means that it was incomplete combustion. And I want to remind you that incomplete combustion can give carbon monoxide and water, and it can give just carbon, which comes out as black soot. So he wants me to balance this equation. How do we balance? Before the arrow, we have how many carbons? We have 2 times 4, that's 8. So I need to put 8 carbons at the after the arrow. I already have 4 and 2, so that's 6. But I need 2 more to make them 8. Then how many hydrogens do I have? I have 2 times 6. So I need also after the arrow 2 times 6 hydrogen. Now explain how one of the products other than carbon may cause a problem. What are the products that we have here? Carbon and carbon monoxide. What is the problem with carbon monoxide? Carbon monoxide is toxic, so that is one possible answer. Or you could say because it gives carbon dioxide gas causes global warming. So either of these answers is correct. Then he says the equation for combustion of butadiene in excess oxygen. Remember, complete combustion will give carbon dioxide plus water. He tells me that the delta H is this number. That means that it is exothermic. It has a negative sign. It's exothermic. Remember, all combustion reactions are exothermic. Complete the energy profile diagram. Again, energy profile diagram means I should show activation energy and delta H. Exothermic means the products are below the reactants because exothermic means the reactants give out heat, and that means the products have less energy. Now, where is the activation energy? Remember, the activation energy is from reactants to the top. Where is delta H? From reactants to products. And in this case, we're going down because it is an exothermic reaction. This question says a student is provided with a bottle containing a colorless solution X. Solution X is thought to be dilute sulfuric acid of concentration 0.1 mole per decimeter cube. The student does some experiments on samples of solution X to try to show that it is dilute sulfuric acid. The student adds a few drops of litmus. Of course, the litmus turns red, and this shows me that it is an acid. Then the student knows that the products of electrolysis of dilute sulfuric acid are hydrogen and oxygen. She carries out the electrolysis using this apparatus. So, of course, in electrolysis, we have a power supply, graphite electrodes, we have test tubes to collect the gases. And then he says, suggest why the student does not use zinc electrodes in her experiment. Of course, the electrodes have to be graphite because graphite is inert. I cannot use zinc because zinc will react with the acid. State what is observed at both anode and cathode during the electrolysis. Let's just review what happens here. We're doing electrolysis of sulfuric acid. He already tells me that it's hydrogen and oxygen, but let's see why it is hydrogen and oxygen. Remember, we're doing sulfuric acid, so these are the ions that I have, H plus and SO4 2 minus, and the H plus and OH minus from the water. Now, which one reacts at the cathode, which is the negative, and which reacts at the anode, which is positive? At the anode, I have a choice between sulfate and OH minus. Remember, sulfate will never react here. It is the OH minus that reacts, and that's why I get oxygen gas. So I would see bubbles of colorless gas. Now, at the cathode, the negative, I have only H plus ions that could react, so I get hydrogen gas. So what do I see at both electrodes? I see bubbles of gas. You could also say bubbles of colorless gas. Which of these tests shows that the gas formed at the cathode is hydrogen? What was the test for hydrogen gas? You should remember the tests. It was burning splint gives a squeaky pop. Remember we said insert a lighted splint or a burning splint, it pops or it gives a squeaky pop. Describe a test to show that the solution X contains sulfate ions. What was the test for sulfate ions? Add dilute HCl and barium chloride, or remember I could also say add dilute nitric acid and barium nitrate. Anyway, any of these with sulfate would give me a white precipitate. The student then does a titration to see if the concentration of dilute sulfuric acid is 0.1. She measures 25 centimeter cubed of potassium hydroxide solution into a conical flask and then adds a few drops of indicator solution. Name the piece of apparatus the student should use to measure 25.0 centimeter cubed. Remember, when we do titration to measure the 25 centimeter cubed of base to put it into the flask, we measure it using a pipette. Okay? The pipette is accurate. It measures exactly 25.0. Remember, we cannot use it for any other volumes. It doesn't have graduations, but it can be used to measure exactly 25.0 centimeter cubed of the base. Then he says the concentration of potassium hydroxide is 0.125. Calculate the number of moles of KOH in 25 centimeter cubed. Okay, potassium hydroxide, I have 25 centimeter cubed, and the concentration is 0.125. How do I get number of moles? Number of moles is concentration times volume. Remember, the volume, if it is in centimeter cubed, I have to divide it by 1,000 before I put it in. So this gives me this number of moles. The equation for the reactions in the titration is this. Calculate the volume of sulfuric acid needed to neutralize the potassium hydroxide. So I'm looking for the volume of the acid. So number of moles of sulfuric acid is what compared to that of KOH. We already got the number of moles of KOH. I look at the equation. I find that from the equation, 1 mole of sulfuric acid reacts with 2 moles of KOH. And that means that the number of moles of sulfuric acid is half what we got for the KOH. So it will be this number. And then I can use that to get the volume. The volume is number of moles over concentration. And that gives me the answer from this equation comes out in decimeter cubed. If he wants it in centimeter cubed, I have to multiply that number by 1,000. So that ends up to be 15.6 centimeter cubed. This question is about reactions involving gases. Potassium carbonate reacts with dilute hydrochloric acid to produce carbon dioxide gas. Remember, any carbonate with an acid would give carbon dioxide gas. Now he's saying calculate the volume of carbon dioxide gas produced when 6.9 grams of potassium carbonate reacts with acid. So I'm starting with 6.9 grams of potassium carbonate. And he's asking for volume of CO2. Again, when he gives me information about something, what is the first thing that I should do? I should get the number of moles. So he gives me information about potassium carbonate. Number of moles is mass over molecular mass. I have the mass 6.9 and he already gives me the molecular mass. So I calculate the number of moles. And then what is he asking about? He's asking about carbon dioxide. So I go to the equation. What does the equation say? The equation says if I have 1 mole of K2CO3, I will end up with 1 mole of CO2. And that means that the number of moles of CO2 is the same as potassium carbonate. So now I have number of moles of carbon dioxide. Now he wants what? He wants the volume. The volume is number of moles times 24. The volume that comes out again is in decimeter cubed. I multiply by 1,000 to get it in centimeter cubed. Then the last question in this paper is talking about dynamic equilibrium. So he has an equation and he says, predict the effect on the yield of carbon monoxide at equilibrium when the temperature is increased. Now, we said when I increase the temperature in a reversible reaction, increasing the temperature goes endo. You should remember that. Increasing the temperature goes endo. Now, where is my endo in this equation? He is telling me that for this reaction, the delta H is plus 41. And that means going forward, hydrogen plus carbon dioxide to form CO plus H2O, that is an endothermic reaction. And that means if I increase the temperature, it will go forward, or the equilibrium shifts to the right. And what is the effect on the yield of CO? That would give me more CO. So the yield increases. This is because increase in temperature causes the reaction to shift to the right, since the forward reaction is endothermic. Are we following? Always remember, with respect to temperature, I look where is endo and where is exo. Increasing temperature goes endo. Now, predict the effect on the yield of CO when the pressure is increased. Now, we said, in general, if I increase the pressure, what happens? In a reversible reaction, increasing the pressure, the equilibrium goes to the side with less number of moles. So where is less number of moles? If I go forward, it gives me 1 CO and 1 water. If I go backward, it also gives me 1 H2 and 1 CO2. So in this reaction, increasing the pressure will have no effect because none of them is less number of moles. There's equal number of moles on both sides of the equation. So increasing the pressure will have no effect. And that's the end of this paper. I hope it is helpful to you, and thank you for listening.